Dear friends, welcome to this electrical engineering knowledge sharing channel. We are discussing workshop 8. Today we are going to discuss about the binary output of intelligent protection relays. What I personally believe that if somebody want to go through this particular binary output videos, better to go first the intelligent protection relays various features and the various input, binary input and its application in the control schematics, which we have discussed in the previous videos, that is video number 68. Then if you follow this output application or binary output application of this protection relays in the switchgear control schematics, that will help to make it understand clearly. So these two videos, that is the binary input and its application and the binary output and its application, these two videos I prefer to look into simultaneously one after another, then it will be more helpful. Anyway, let's discuss this binary output, intelligent relay binary output and its application in the control schematics of the switchgear. Under these videos, we'll also try to cover another two small aspects. One is the various LED indication lamps available on the protection relays, how we can assign those relays for the various functions, as well as another important feature of the intelligent protection relays. In addition to these protection functions, various control and interlocks, in addition to these features which we have discussed in the previous videos, another important feature this protection relay that it has a metering features. So these various parameters of the switchgear also metered or can be monitored by metering the values through the protection relays. So in that case, using of the analog meters may not be essential. So that is another important potential of the intelligent protection relay that also we'll try to cover under these videos. So we have already discussed that protection relay can be ordered, or we can purchase the intelligent protection relay with the multiple inputs and the multiple outputs. We have said that we are considering about 28 outputs and we have considered 48 inputs. So those outputs means we have already said what is these outputs. Actually this relay, this intelligent relay based on the input function and the configuration, how the input functions are configured. That input function means this could be analog input as well as binary input. Based on this input, binary input and the analog input assignment or the programming in the software, we can get various output. This output actually potential pre-contact. Those contacts actually the contact of some read relay, small relays in the protection, main protection relay has also a lot of small read relays. Those relays output contacts we talked as a output binary output. So those binary output we already said that it is shown by the output contact. This is how this is one of the binary output. This is one of the binary output. This way you can order as you like, maybe 28 binary output you can order, and this binary output we tag as binary output number 1, binary output number 2, binary output number 3, like this. This way you can go up to binary output 28. So these are the 28 output contact we are assigned. We are telling this particular protection relay has 28 binary output. Now this binary output, how this binary output will be using in the switchgear control schematics. Now in the control schematics we have already discussed the closing circuit, tripping circuit, alarm indication circuit, auxiliary relay circuit. In all these circuits, this binary output we can use suitably by proper configuration. So we will be discussing all these, how this binary output will be using. Suppose in a closing circuit, how we can use it, tripping circuit or opening circuit, how we can use it, alarm indication circuit, how this binary output can be used. Similarly, auxiliary relay circuit, how this alarm indication can be used. We will discuss all one typical of all this binary output in each circuit, okay, to make it understand. So this relay, this particular intelligent protection relay, we are considering suppose 28 binary output. Now suppose we want to assign binary output 1 and binary output 2 to the tripping circuit or the protection lockout relay circuit. How that is? This we are configuring the binary output 1 will be activated. Means this is a open condition, means it is a 0 state. This binary output will convert it to 1 state, means this contact become NC, that means activating, that means the corresponding read relay will be activating under condition. How what is the condition? If we configure the relay that the analog input, that the suppose the analog input we are considering the current input. Suppose the current input or the CT current which we have given in the previous video, we have discussed that the CT input which is given as the analog input to the relay, if that analog input parameter is cross the setting value or cross the limiting value, suppose I am setting the analog input CT current value 2 ampere. If the current goes above, suppose it is a 1 ampere CT secondary. If the current is going beyond 2 ampere, if the current through the relay, if the input current to the relay is more than 2 ampere, then we are telling it will be treated as a overcurrent condition. That means the circuit is subjected to the overcurrent condition. Under that overcurrent condition means IDM to overcurrent relay, that is 51 relay, 51 function. As we have said, this protection relay has a multiple protection functions. Suppose we are telling when the protection relay sense the input current magnitude is more than the 51 setting value, which is 2 ampere for the 1 ampere input, then 51 this condition when the relay will sense, immediately relay will activate the binary output 1. If we configure or if we program the relay has, we have already said, the relay has a software which can be configured or reprogrammed. All the protection function, all the alarm indication, all the output, all these output functions can be configured based on our requirement. Suppose, so based on that, suppose I want to use binary output 1, binary output 2, binary output 3 for the protection functions. How is that? So when this particular feeder protection relay is cross the current condition in the circuit is cross the overcurrent limit 2 ampere, then if we program that this condition immediately activate the binary output 0 1, then immediately when this cross the 2 ampere, immediately binary output these will be become NC. Similarly, I said that not only this, it is also when if further cross suppose 5 ampere, then it will be considered as an instantaneous 50 function. If it cross 5 ampere, then also this output contact will be activating. So this binary output I can configure both for 50 function as well as 51 function. That means when the instantaneous overcurrent as well as the IDM to overcurrent is operating, when the relay is sense this operating overcurrent condition, immediately relay will activate the main relay function. This relay CPU will give a command to the output contact B01 to change over. Then the output contact 01 will be activating. Okay. Now this output contact, how I will use it? This output contact I will use, we have seen all the protection functions of the relay is activating the lockout relay. So how I will do that? So what I will do over here, the moment I will draw the now the how this lockout relay will be activating the moment B01. So I will use here B01 contact. This is a B01 contact. It is going to where we have already set the lockout relay. There is a NC contact, and this is a lockout relay 86 lockout relay. This is a negative side. This is a positive side. Suppose it is a under 20 volt. Positive, it is a 120 volt negative. Okay. So now this is a locker. This is a B01 output. I am configuring for what? 50, 51. Then this is a NC contact of this. This is a set. We have already seen in the tripping circuit of the lockout relay how it is. It has a two coil. These are interlock. One is a set coil, another is a reset coil. That is a reset. And then this is connected through a NA contact. Sorry, I am drawing in the American practice. So this is a connected through NO contact, and then it is I am drawing up to this point. Okay. So the moment B01 activating, B01 means what is the B01 representing? B01 representing overcurrent condition, either IDMT overcurrent or instantaneous overcurrent or IDMT overcurrent. With any of the function operating, immediately B01 will activate it and this will close this one. Then this lockout relay will operate and the lockout relay will trip the breaker. That is we have seen. Okay. So this is one way I can do that. Similarly, what I can do again, suppose B02 function. B02, this output contact, how I configure? I am saying when the feeder goes under voltage, that means when the feeder voltage, the PT input, we are giving 110 volt PT. In the previous video we have discussed PT analog input we are giving as a 110 volt. This 110 volt, when it goes less than 80%, immediately it will consider as under voltage. When this PT input voltage is less than 80%, immediately this relay will give a command. When this analog input goes 80%, immediately it will give command to the B02 output relay or output contact, binary output, to activate. Then immediately it will become NC. So if I use here another B02 over here, okay, B02, this will send under voltage condition. So this under voltage protection also I can include over here. When this B01 or B02, any one of these activating, immediately lockout relay is operating and the lockout relay will go to the tripping circuit. This way, suppose this is a differential, this relay also has a differential protection. So if when this 87, suppose 87 is operating, the moment 87 is operating, differential protection operating, this protection function is operating in this relay, we assign when 87 will be operating this function, this will activate the B03 contact, B03. So then we'll put another here, it is a B03, it will come over here, it is B03. That means when overcurrent condition is existing or where there are under voltage or differential operated, any of this case, immediately this lockout relay will operate through. This lockout is a separate relay, this is a separate relay, we have seen already, this is a separate relay, and these are the output contact, the main protection relay, which we are configuring based on the analog values. This way I can configure the output contact for the protection function. Now this we have shown in the previous, in the tripping circuit, this lockout relay is manually reset through the push button. But if I want to make a auto reset, suppose these are the protection functions, this protection function activating the relay. When this protection function come to the normal, I want to, this relay will be automatically reset. Now if we want to auto reset, then what I have to do, when this 86, this corresponding protection function has come back to normal, or this protection due to the fault is cleared from the line, then the corresponding function, the B01 or B02 will come back to normal. So if B01 come back to normal, at that time we can configure B04 as activation. The moment B01, suppose we want to deactivate, auto reset this relay, so any one of this protection function or all of this, we can make a logic, any of the protection function after operation come back to normal, or all of this come back to normal, or any two of this come back to normal, immediately B04 will be activating. If we configure this way, B04 will be configured when this protection function after operating come back to normal, then only B04 will be activating, and then that B04 will be connecting over here. So this is a B04. Then what will happen? B04 is not, the moment these are activating, immediately lockout relay set coil is operating, and lockout relay operating, it gives output contact, it will trip the breaker. After that, we have identified the fault and we have cleared the fault, then this overcurrent condition will be get out. The moment overcurrent condition get out, this contact become NO. So then this, what will happen, when this condition become NO, immediately this contact will be identified that fault has cleared. So then these will be activating, B04 will be activating, and it will activating the reset relay, because this reset relay, this is the moment it is operating, it become NC, it become NO. So this reset relay is operating and the relay will come back to normal. So this is the another way we can do instead of push button. If we want to auto reset, we can use one of the output contact, or we can do manually, we can do the reset through the manual push button. That is also we can do in this way. This is also we have shown in that way. So it is another application of the output contact in the protection circuit. This is one of the protection output contact. Similarly, This output contact of the protection relay we can use for, suppose we want to use in auxiliary relay circuit. How is it? Suppose I have this feeder has a 8-volt relay. This is the CBCT is there. This CBCT is connected to the supply is giving to the relay. Okay. Then the relay will sense the 50G, the instantaneous 8-volt. When the instantaneous 8-volt is operating in the main relay, then we want to multiple these functions, multiply this contact 50 function operation. When the 50G operating, suppose at that time all of the output contact, suppose it is a B output contact 10, this is activating. Suppose we are considering that we are programming the moment main protection relay sends the CBCT supply, and when the unbalanced current is coming above the setting value, immediately 50G will be operating. This 50G will be activating this binary output 10. Okay. Now this 50G operation, I need to copy it to another switchgear or somewhere else. Maybe in the DCS we want to monitor the 50G operation. In the other control panel also we want to monitor the 50G function. In this switchgear also this 50G function, I want to trip the circuit breaker. So there may be multiple requirement for this 50G function. So in that case, only one contact will not be enough. In that case, using this particular contact, I can use the auxiliary relay to multiply the contact. How that would be? Suppose we want to multiply this 50G function, protection function operation with the multiple outputs. So how we'll do that? Suppose this is the control supply 120 volt. Now what I'll do? I will use one of the output contact of the relay. Suppose binary output 10 I am configuring. So binary output 10 will be operating when this 50G function, that means the CBCT supply to the main protection relay, identify that there is a 8-volt on the circuit, and then immediately 50G function will operate. This 50G function trigger this binary output 10 to activate. The moment binary will activate, what will happen? This binary output NO contact will become NC. The moment it give a triggering command, it become NC. Then what I will do? I will connect this to a auxiliary relay coil. This is A1 and A2. This is going to negative 120 volt. Negative. This is A1, A2. So this is the coil. Okay, this is a coil, and this has a multiple auxiliary contact. Like this, multiple auxiliary contact I can draw. So the moment 50G condition is prevailing, immediately binary output 10 will be activating, and this 10 will be activating this auxiliary relay. That auxiliary relay have a multiple contact which I can design as per our requirement, and this contact will be taking to the various places. Suppose this particular contact, so the contact number 1, suppose this is contact number 1, I am taking to DCS for the indication. Suppose this is I am taking to control panel for indication. Suppose this 50G contact I am taking to other switchgear for tripping. So I can use this way. So this way, this binary output of the main protection relay we can use for the multiplication or using auxiliary relay. This way relay output contact also we can use in the auxiliary circuit. Similarly, this binary output we can assign for the alarm indication purpose. How is it? Suppose when I am telling we want that when this overcurrent condition, suppose this overcurrent condition, when the overcurrent condition is operating, at that time we want this overcurrent condition, operating condition to be alarm or to be alarm to the annunciator. Okay, so how we can do that? This, if we specifically we want only the overcurrent condition, or suppose critical, suppose differential operated. When the differential protection operated, at that time we want this specific differential operation to be annunciated in the annunciator. In the annunciator, we have a protection operated. That common annunciation is there through the lockout relay 86. We have seen in the previous video, in the previous screen, that 86 how it is operating with the differentiation. But if we want specifically only the differential operated, that protection function to be annunciated in the annunciator, in that case, differential operated that function to be copied there. So how we'll do that? In this, in the previous screen, we have seen that when the differential operated, that particular 87, when the 87 function is operating, Then one of the binary output, suppose that was a B03, right? B03, this binary output we have connected to the lockout relay, right? We have connected to the lockout relay, 86 lockout relay. We have connected this. This is a differential protection, right? This is the differential protection operated. So this contact is going to 86 lockout relay, and that is using for the tripping purpose. Now I want, when the differential protection operated at that time, I want that particular function to be enunciated in the enunciator. So in that case, another output contact of the main protection relay, suppose that is a contact number binary output 12. So this binary output 12, I want to program or I want to configure for the enunciation purpose. So how will do that? I will program in software the binary output I will assign to the differential protection. The moment main protection relay identifies that there is a differential protection operated, there is a fault in the circuit and the differential protection operated, this differential protection 87 function will activate not only B03, it will activate also B012. Then this B012 contact, this is B012. B012 contact where I will use in the annunciator circuit. We have seen annunciator circuit, this is the LEDs, and then this is a reverse blocking, another diode is here, reverse blocking, and it is going to the 48 volt negative. Suppose this is a 48 volt or 24 volt positive, and this is a 24 volt negative. So the moment differential protection operated, it will not only treat the breaker through lockout, at the same time this output contact 12 is configured for this protection. It is linked with the protection function 87. Then immediately this, suppose this is the window number 16, immediately window number 16 will be, it will be lit and the corresponding one will be sounding. So I will understand differential protection operated. Differential protection, I will give this annunciation or differential protection. In this way, the output contact also I can use in the as application. Okay. So these are the three applications I have discussed. Now this protection function also we can use in the closing circuit and tripping circuit as a command. How we do that? In the tripping circuit or closing, suppose I want to close the breaker from the relay itself. We have already seen, we have already discussed in the closing circuit, we can close the breaker locally and remotely. From the locally we can close through the closing switch on the switchgear panel. From remotely we can close the breaker from the DCS, from the control panel, from the other location. In addition to this circuit breaker can also be closed from the protection relay itself. For closing purpose, what you need? You need a command. Command means one digital input, either through the push button or through the switch. In the previous case, we have given through the, in the local operation, we have provided by the switch. At that time, we discussed, we have also said that it can be done through the push button also. And now in the remote case, how we did, in the case of DCS, we give from the keyboard command, and that is that digital command is going to, that is a small 4 to 10 milliampere signal, is going to a micro relay. The micro relay output contact we are using for the closing purpose. Similarly, from the protection relay itself, there is a button. If we press the button, we can assign one of the output contact. One of the output contact will be activating. When we press that particular closing button on the relay itself, there is a close open button is there. Breaker close, breaker open. If I press that close button, then the close button will be activating one of the, we can assign which output contact we want to assign. Suppose we want to assign output contact B016. We want to assign for the closing circuit. Then what will happen? This is a 120 volt DC positive. So this is a B016 output contact of the relay, which is activating by this button on the relay, closing button. Then it will go to the, through the various interlock. There is isolated interlock, all this thing in the closing circuit. It will go to the breaker closing coil. This is a breaker closing coil. So when this will on, immediately breaker will be closing. So these are binary output also we can assign for the closing purpose. It is not only this push button, it is also can be assigned. Suppose I want to close the breaker from the DCS through the relay, not directly. So in that case, how to do? The DCS, when I issue the command from the DCS closing command will come into the relay input. So in that case, DCS from the DCS, this is a 120 volt DC, okay. Now from here, what I will do, this is the binary input. Suppose binary input number 5, I have given from the DCS. DCS, when I issued the DCS command, there is the output contact. That contact is connected over here, DCS output contact. that contact is coming to the relay, this particular relay as a input. This is as the input, this is connected to the input. Suppose input number, this is a binary input 5. Okay, this command is a DCS command. From the DCS, this command has come. This is a DCS command. Okay, this is coming from the DCS to the relay as a binary input 5. The moment BI5 is high, then what I will do, the moment BI is high, this input high, immediately I can assign one of the contact in this output contact. Suppose I want to assign output contact 20. When the BI is 5, immediately I can make the logic. When BI is 5, BI5 is high, means it is activating 1. Immediately B020 will be high, means it will be closed, and then the breaker will close. In this way, remotely also, locally as well as remotely, using this main relay binary output, I can close the breaker. Similarly, I can trip the breaker in the same way. Similarly, as we have done the closing circuit, now in the same way we can trip the breaker. So that I can do two way. Suppose there is a button on the breaker. If we press that trip button, then breaker will trip. As same way as we discussed in the closing circuit, what will happen when I press this button? Then this button I can make the logic. When this button is high, then it will activating one of the output contact, output relay. Suppose this push button I am assigning this push button which is on the relay itself, that is activating suppose one of the contact binary output, suppose 21 BO 21. So when this I am pressing the button, tripping button on the relay, then binary output 21 will be activating, and that 21 will go to the trip coil and it will trip the breaker. This way I can do that. Similarly, if I want to trip the breaker using output contact of the relay from the remotely, that also I can do that. How I do that? In that case, that remote trip command. Remote trip command means either is a push button contact or switch contact or relay contact. That output contact will come to one of the input. So here suppose I have the input number BI. It is a binary input, suppose 20. That is I am programming for the remote tripping through the relay, not directly through the relay. So what I will do? So here I will put the remote. Suppose this is DCS open command. I am giving the opening command from DCS. Okay. So DCS, it is a DCS open command. This open command is coming to the binary input 20. So now I will configure when this binary output, suppose it is 22. When this binary output 22 is high, immediately what will happen? It will activating binary output 22. Suppose it is activating binary output 22. I make the logic when BI 22 is high, high means is 1, is equal to 1, means it is activating immediately. B022 will be activating. B022 is a binary output 22, and this B022 will be activating the trip coil and the breaker will trip. In that way, also the binary output I can use for the tripping purpose. So this way, this binary one, main intelligent relay binary output, it has a different application. We can use for the multiplication of the contact of the any function, various functions of the switch gears. It can be used for the alarm indication purpose. It can be using for the tripping purpose of the lockout or through the lockout relay. It can be used for the simplify or multiplication of this protection function for other application. It can be used for the breaker closing purpose. It can be using for the breaker tripping purpose. These are the various application of the output contact of the relay, and these are wired up in this way. So these are the interface with the switch gear of the protection relay output contact. In addition to this, we have said that protection relay has a multiple indication lamps. Those indication lamps also we can, suppose there is a 16 indication lamps. Suppose this is the relay. If this is the relay, on the side of the relay you can see there is a lot of indication lamps over here. Okay, these indication lamps we can configure for the various purposes. So this is indication lamp. Suppose this is a CBO on, you want to configure CBO off. Suppose this is a protection operated, yeah, protection operated. Suppose DCS command come, DCS command issued. This way, the way I want to configure the indication lamp, I can configure it. How I will configure? Each indication lamp corresponding input to the indication lamp will be coming from that particular function. They either through the auxiliary contact or through the multiplying contact or from the main protection relay itself. what about the way this function want to configure? We can configure the indication lamp in this way, various functions. And then the last thing is this protection relay also has a very important potential. It can meter all these parameters of the electrical circuit. In the electrical circuit, normally in the old days and even nowadays, we use a multifunction meter. The multifunction meter monitor all the parameters. This protection relay also do the same thing. That means protection relay has a dual function, one triple function. One is a control interlock function, one is your protection function, and it can do the metering function. But multifunction meter only do the metering function. So this protection relay can be considered as a protection relay along with a multifunction meters. The various parameters which can be monitored by the protection relay, that is your current, voltage. You can measure line to line voltage, line to phase voltage. Here also you can measure line to line current, line to phase current. Sometimes you can make the residual current also. Some current, summation of I1 plus I2 plus I3, that also you can measure. Number 3 is active power. Active power means kilowatt. Then it can measure the reactive power. Reactive power means kVAR. It can measure the total power, kVA. Total power, kVA, it also measure. It can measure power factor. So these are the various parameters it can measure. Some of the high grade protection relay also it can analyze the harmonics or repeats also it can monitor. It can also, in some intelligent version, more intelligent version can monitor the various harmonics flowing in the power circuit, because all this function, how it is metering from the analog input. We have given the analog input, we have seen already. We have given the voltage input to the relay, voltage input, and then we have given the current input from the CT. It is coming from the field CT, it is coming from the line PT, or it is coming from the bus PT. From this supply, it is coming to the relay, and relay is converting this corresponding 1 ampere or 5 amperes current to the respective relay suitable current. Here is a PT 110 volt PT supply is converting by the relay inside the corresponding required voltage, and then it can, the relay is configured in such a way, relay is programmed to measure all these parameters. So these all function parameter you can get available on the relay from the relay monitor. There is a small monitor. On the monitor you can measure all these parameters. So this is another important potential of the relay. So relay can do the protection functions as well as it can do the metering functions. So all the metering functions it can available in the relay. So these are the major function of the intelligent protection relay. So in a brief, this intelligent protection relay has a multifaceted facilities. It will do its main protection functions. Along with this, it can control the circuit breaker. It can give all the alarm indications of the circuit breaker. It can be used as a switchgear interface for the various control interlock indications. It can use for the metering purpose. It can use for the various outside solid state devices like a laptop, hard drive, various interface. It can be used for the serial communication through the serial port. It can be used for the optical connection to the remote end also. That facility also there. In addition to this, it has an overall CT-PT interface facilities there. It has the input-output functions are there. And finally, it has a watchdog system which is continuously monitoring the relay software as well as hardware. If any one of these fail, immediately the watchdog system will give an alarm through the output contact, and that will indicate there is a problem with the relay. So these are the overall of the intelligent protection relay potential and this application in the switchgear interface in the control and schematic schematics. This is all about the protection relays. So I will be closing this videos at this point. So I would like to request all of you again. So when you are looking this this particular video, please look into the previous video where we have discussed about the protection relay potential and this input various interface details, so that if you go through both the videos together, then it will be easy to understand, or it will be more clear to all of you. With this, I am closing. Thank you for your partnership and thank you very much indeed. Thank you.